Good morning. Assalamualaikum. Last class we had done up to here, right? The for the composite curve. Okay, we had done with this example, composite curve. So I hope you now know how to plot the composite curve, okay, for hot and cold. Okay, so today we will find out on the pinch point. Okay, pinch point, the temperature, hot pinch and cold pinch. Before we generate the curve to find out the pinch, we must plot composite curve first. Okay, for both hot and cold, then we combine. Now, if using the same example over here, okay, the same example over here, where we have two hot and two cold. Okay, two hot and two cold. So first step, I would suggest you to rearrange the stream first. Okay, categorize them into hot and cold so that easier for you to see. Okay, let me open my cell. Okay, this one from the previous class where I take one hot and one cold, so you come out with the composite curve. Okay, from the last class. This one hot and one cold. Now, if you have two hot and two cold, this is the table from the example here. Okay, this one, this table. So I put it here, the same table. Okay, then I would suggest you to rearrange it, categorize them into hot stream and cold streams so that you can see the difference in T supply and T target and also the delta H. Okay, so put up all the data, delta H and also the CP. CP here is the heat capacity flow rate. Okay, this part. Now, to generate the composite curve for all streams, as I mentioned in the previous class, I would suggest you to do hot stream first. Okay, start with hot stream first. Now, okay, here is they showed you. Okay, the slide show you hot streams. CP015. Okay, this one is H1. Hot 1, hot 2. Yeah, wait here. Okay, this is hot 1, hot 2. Okay, they combine. Plot in on the graph paper. Wait, let me copy and paste the table over here. Okay, I explain first, later we try to do. Yeah, hot 1. After we rearrange, hot 1 CP1015. Okay, this one as hot 1. Hot 2. Okay, now C1, C2. Okay, now plot hot 1 from, the hot 1 is from T supply 250, T target 40. Okay, so heat capacity, delta H would be 31.5. Okay, how to plot this? This is y-axis. The temperature is y-axis. How about the x-axis? What is the coordinate for T supply? T supply is y-axis at 250. Here, 250. What is the x-axis? 250 over here. This point. What is the x-axis at 250? Huh? Delta H. Okay, so the distance between T supply, T target, it should be 31.5. Okay, so 250 according to the delta H will be at 31.5. Okay, so here the coordinate will be 31.5 and 250. 40 is the T target. Okay, so from high to low, 40, let's say we start from 0. So here would be 0, 40, the coordinates. Okay, now to plot the next hot stream, you should know where you should start to plot the next hot stream. Okay, hot stream 2, you see over here, it starts from the end of H1. Okay, here. Okay, it starts at the point and the end point from H1. Then start H2. Okay, so the T target over here would be, T target is 80. Okay, so now 80 T target, T supply is 200. So the coordinate for T target H1, 80 over here, would be x-axis starting from 31.5. Okay, you should continue. The first stream, continue with the second stream. Okay, the delta H. Now the coordinate would be 31.5, 80 for this point. T target, T supply is 200. Now, how do we know the x-axis of this T supply? Delta H. Okay, we know that H2, 200 to 80, you have 30 delta H, the distance. Okay, delta H is the x-axis. So from here to here is 30. The distance is 30. Now the coordinate for x-axis, coordinate for here, x-axis, 61.5. So 31.5 plus 30. So here will be 61.5. Okay, so coordinate for T supply over here would be 61.5, 200. Okay. Up to there, can? You must know how to plot first each of the stream.
When the H1 will finish there, so H2 will start it from
Correct.
every time.
Yes. Okay. So if you have third stream, the H3 will start from this point, 61.5 x-axis. Okay, and it depends, the distance depends to the delta H. Okay, the end of H, the end of first stream will be the starting of H2. Okay, the delta H. Okay. Now, how we want to combine these two? This part, the top one, okay. This part, we will move to this point. Okay, we move to the end of H2. From the y-axis, okay, you can see the overlap area. Okay, check on the overlap area on the y-axis. Y-axis, this is the overlap area, y-axis. Okay, so the overlap area over here is the point that you should combine. So the combination point is from here to here. So combine this point. Combine these 2 points. That's how you get into this. Here and here. Okay, now I show you in words. Yeah. Okay, just now we had plotted the H2 and H1 and H2. Okay, from 40, sorry. Okay, let me check the details. 40 to 250. Okay, 40 to 250. Here is 250. This one, 80. Here, 200. Yeah, 200. Now, this is the plotted 2 streams. Hot stream, 2 hot stream. So how to combine? Just now I mentioned the overlap area. This, so the yellow area. This is the one that they overlap. So how to combine? From this point, okay, from this point, combine to this point. Okay, so how to do it? Okay, combine from here to here. Focus on the red color one. Now this one, move to the last point. Okay. Hey, wait. No. This one, yeah, let me check. Okay, now this part here is quite tricky because the hot stream H2 I show it again. Revert back to the original one. Okay, the thing that you need to confirm here is the total distance must not exceed 61.5. Okay, here. The H2 ended at 61.5 here. Yeah, 61.5. Now, the total distance that you should have must not exceed 61.5. Okay. Now, since the overlapping area from H1 and H2 at the end of H2, sorry, at T target of H2, right? Okay. So here, the last point should be at 61.5, meaning that this point, this must fall at 61.5 on x-axis. Okay, so here must fall at 61. The last point over here should be 61.5 and 250. The last point. Okay, so now to combine the overlap area, we drag to the point. This one is the correct one. Okay, always check your total distance, total enthalpy must not exceed from the combination of both. In this case, it is 61.5. Okay, the T supply for H2 and at 61.5. So once you combine both streams, it must not exceed 61.5. Okay. The first one just now that I showed just now, the first one, which I just dragged to the last point of H2 over here, this is wrong. Because you see, if you drag to the last point, to the point here, total distance on x-axis will be more than 61.5. Okay, so that's why if this is the case, you should take the distance. You should calculate the distance. That's why I draw the gradient over here, the tangent. Okay, the blue color. In order to know how much to move. Okay. Yeah. Any question? Okay, so just now, since we combine the streams, the CP for the combined stream is the summation of both streams. Okay, what I mean is, you see over here, once we combine, the CP becomes 0.4. How get 0.4? 0.5 plus 0.25. Combine both streams. Okay. Any question? Now this one is for hot. Same method for cold. Okay, now for cold, plot both the cold stream, which the cold stream is from 20 to 32. Here, 20 to 32. Okay, then the C2 from sorry, not 32, sorry. C1 from 20 to what point? Huh? 180. C180. How about the H? X-axis. 32. Okay, how do you know it is 32? How do you know it is 32? Yeah, delta H. Delta H is the x-axis distance. Okay, so that's why from 0 to 32 for C1. Now C2, plot at the end after C1. Okay, from 140 to 230. Now, what is the x-axis for this target over here? X-axis. $59. Okay, so this is the coordinate for T target C2. Okay. Then we look through which part that they overlap. This one. Okay, so now drag the point from this to this. This one you can simply drag from here to the end over here. Okay, so this is the combination area. Okay.
How to find
24. Oh, okay, here, this one. Okay, how to find this 24, 20, and 15? How it gets these values? Sorry? Huh? extrapolate. You can drag down from here. This is the point that we start to combine, right? So here, will be the third category, the third area over here. Okay, how do you know the value? This point, you can see what is your y-axis, what is x-axis. Okay. How to get which one? This one. This is the point that we combine the overlap area, right? Okay, this is the point that they overlap. So here, yeah, same as hot stream. Okay, same as hot stream just now. So hot stream here, you see, this one is the area. So this is the first area. Between this and this is the second area. And here is the third area. Okay. So that's why here it shows the 7.5. This part is 6. Okay. Any question? Rachel, how do I get 7.5? Over here? Why you do not know? I have explained just now. Why you not sure? I already explained just now. Focus to my lecture. Stop playing your phones. Focus to my lecture. How do we get this 7.5? Can read? Distance between the final combination point to the last point. Okay. The 6 here, the initial point until the first combination point. The first that we combine. Okay. Okay, so here same goes for cold stream. Just now we combine at this point and this point. Then we drag. Okay. Now CP 0.5. How do you get this diagonal? How do you get CP 0.5 over here? Even? Huh? Combine. Combine the two because we combine the stream now. Okay, the 0.5 here is total of 0.2 plus 0.3 because we combine the stream, so that's why here we get 0.5. Okay, each phase, each stage over here, the CP is different. Okay, because we combine the two streams. First stream CP 0.2, second stream CP 0.3. Okay, the combined part is the total of 2 CP. Okay. Yeah. Now, after we do the combination, plot into the same graph. Okay, the blue one here. Let me make it bigger. Now, after you combine both hot and cold stream, the next step is to find the pinch point. Okay, the pinch. Overlap both streams, hot and cold. Okay, just now we had plotted the red one is hot, blue one is cold. Now move the hot horizontally. Move the hot until you get the pinch point. Delta T 10 degrees C. Delta T mean. Delta T mean here from hot to cold. Okay, delta T mean. So here you move the cold until you get the delta T mean is 10 degrees C. So the pinch is at this lowest point. This is the pinch point. You must have your delta T min. Set your delta T min. Okay, remember the delta T min is the temperature that drives the heat transfer. Yes. Ask questions so that you understand. Huh? How do you find pinch point? Move the cold stream. Okay. I start again. Huh? This is the original of hot and cold. Okay, this when you overlap them, it will look like this. Overlap both two, hot and cold. Now move the cold stream until you get your delta T min 10 degrees C. Move the whole thing because we place around with the delta H. Okay, move the whole thing. Now let's say here is the delta T min 10 degrees C. Okay, here. Here, this area. Delta T min is 10 degrees C. So that is your pinch point. Pinch for hot and pinch for cold. So that temperature is your pinch temperature. Okay, so drag to find out what is the pinch temperature for hot and cold. Delta T min, yes. Delta T min. So that's why you need to set what is your delta T min. Yes. Yeah. Correct. Delta T min is the one that you need to set to find your pinch point. Okay, remember the previous slide that we have? Okay, I go back to slide 16. Okay, in your slide, it is slide 16. Wait, I go back to slide 16. In my slide, it would be which one? Here, the importance of T-means. Okay, here it mentions you can either set your delta T-mean or the Q that you want to recover. QH mean, QC mean, the Q that you want to supply. You either set your delta T mean or you can set the heat that you want to supply. QH mean or QC mean, the minimum that you can. Because from the delta T mean, later on you will design your heat exchanger. It involves the area, everything. The A delta T, which requires in order for you to design the heat exchanger. Okay, so this delta T mean is important. You cannot go too low, you cannot go too high, because it will affect the design and the surface area of your heat exchanger. Okay. Yes. How to find the pinch point? How you can determine the location? Okay. I reverse back. Pinch point, huh? Okay, now I repeat again. Your delta T mean just now already set as 10 degrees C. Okay, now this is the original where the cold stream start from what? Wait, let me check again. Cold stream start from 20 and hot stream start from 40. Okay. Now here is 20 and 40. Now this curve is the one that we get from combining both streams for cold and hot. Up to there, can huh? Now when you overlap the curve just at their original position. Okay, you will have like this. Now we want to find the pinch point where the delta mean is 10 degrees C. Remember, delta mean is between hot and cold. Okay, hot and cold. Now we move the cold stream until you find the delta T up to 10 degrees C. So the delta T mean here, until you find 10 degrees C between the hot and cold. So from this figure, okay, here, let's say from the plotted one, this one is delta T mean. The difference is 10 degrees C. What? Two graph paper overlap, then you find.
How many marks do you have? How many marks?
How many marks not yet determined? Now you need to know how to draw it first. How to draw it first. How to get the point. Okay, how to get the point. Any other idea that you have? Because the crucial part, we do not know where is the point that can have delta T mean 10. So that's why you need to overlap the two graphs. Then move horizontally. Okay, that one is if you draw manually, you need to do like that. If not, you do not know where is the point. What's the big deal? Yes. Don't use that word in front of me. That's why you should practice. Then you know how to move it. What? Up to you. You can use your own creativity. Okay, this is the one method to find out the pinch point. Manually plot the graph. Okay, we have another method which is the PTA. What is PTA? What is PTA? This we call as composite curve to find the pinch point. Another method is using the PTA, problem table algorithm, the one that you do the heat cascade. That one you don't need to plot the graph. Okay, because most of the time it will involve a few hot and cold streams. It is tedious to plot all the streams. Okay. Now I go one by one. Here up to here. Any question? How to do it? You can use your own creativity. That is the method. Okay, to find the pinch point. Now the pinch point is the point at the lowest temperature difference. So here is pinch for hot stream. Here is the pinch for cold stream, the temperature. Okay. Now moving forward. Okay, so from just now we get this point as the pinch when delta T meet the requirement. So once you get the pinch point, then you can find out the rest. What is your QH mean and QC mean? Heat recovery, this is the maximum heat recovery. Okay, so meaning that using this pinch point, you need to supply this amount of heat in order to get, in order to proceed, okay, in your process flow. You need to supply this for your heat integration part. Okay. So the difference here is your QC min. The difference at this part is your QH min. Hot utility you need to supply 7.5. Cold utility, the minimum is 10. Okay. Any question? Now this is the differentials when you have different T min. Okay, so the different T min, then you will get this QH min and QC min. If you extend the delta T min to 20, so your QH min more compared to delta T min 10 degrees C. Okay, so the height here it shows increase the delta T min, you will increase the heat supply. Okay, and your heat recovery also will decrease. Okay, any question? Now this one is to compare the different delta T min. Okay, this is delta T min 10 degrees C and 20 degrees C. So by the cost versus delta T min, you can find which delta T min is optimum for your process. Okay, so plotting this, you can see which one is the optimum one. Okay, now I want to proceed with the exercise. Okay, come, let's try. We do it step by step. Okay, since we are running out of time, I'll show you step by step, but later on you should practice. Okay, you should practice. You can follow with your own graph paper, but you will need quite a few. Okay, now, given this table, you have 4 streams. One streams, not steam, streams. Okay, streams. You have 2 cold and 2 hot. Given TS, TT, CP, and delta H. Okay, delta H is important for you to plot. Let's say delta H is not given. How you want to find? How do you want to find? Huh? Correct. Correct. Okay. Thanks, Frank. Now, my question just now. Frank already answered, but I want to know the others. If delta H is not given, how do you want to find the delta H? Basil. From the CP, then change in temperature, correct. From CP over here, you see the unit kW over C. Okay, so CP over here is equals to delta H over delta T. Okay, delta T here means supply and target. The difference between supply and target. So if it is not given, you can find from the CP value, multiply the delta T. Okay, so CP multiply with delta T. So CP multiply with 135 minus 20. You get the same. Rachel, do you get the same? What do you get? CP multiplied by delta T. Celsius? What do you get? CP multiplied by delta T. What do you get? Huh? Yes, you should get 230. Okay, so if delta H is not given, you can find it from CP and temperature data. Okay. Now, this question asks you to plot the heat transfer composite curve for the following T min. Okay, we just do T min 10 degrees C first. And it asks you to determine the respective QH min, QC min, and Q recovery. Okay. Now we go step by step. I copy back this, easier to see. Okay. Now we have let me put this aside first. Okay, we start one by one. Now, you need to find out the coordinate. Hot, we start with the hot stream. Okay, hot stream. Now, hot stream, you have two hot stream. Which one you should start first? Stream 2 and stream 4. Okay, we start with stream 4 because lower than stream 2, the temperature. Okay, now TSTT. Now, stream 4, focus on stream 4. T is 30. Temperature is 30. What is the x-axis over here? 30. 30 is here. What is the x-axis? What's the x-axis, Rachel? What? Sorry? Huh? Delta H, okay. What is the coordinate for this x-axis? What is the value of x-axis for this 30? Huh? 180? Frank, how about you? 0. 0. 0. X-axis should be 0. Here. Now the T supply is 150. Put it here. Now T supply is 150. Y-axis. X-axis? Okay, where the delta H go? Here, the amount of the delta H. Okay, 150 is the y-axis, which we plot over here. 150. Okay, 150. But we should know where to put the point. At this 150, where is the x-axis? Based on the delta H value, 180. Okay, so 180 is somewhere here. Here. Okay, so drag from 150 to 30. That is your H4. Right? So up to 150 at 180 here. Right? Agree? Here. Right? Okay, so this is H4. H4 from 150 to 30 with delta H of 180. Okay, so from here to here is 180. Sorry, here to here is 180 kilowatt. Okay, you can try to plot. Now, this one is H4. Next, hot stream, which is from 170 to 60. 170 going down to 60. Okay, to 60. Now, where to start the 60? 170 to 60. 170 to 60. Okay, T targets. Now, the point of 60. x-axis for 60. 180, correct. 180. So 60 for the hot here. The x-axis would be 180. Starting from here. So 60 should be over here, 60. Okay. 170, what is the x-axis? Delta H is 330. But your x-axis is not 330. Remember, 60, we start from 180. So from 180 up to the last point must be 330 delta H. 330. So, what is the x-axis? $150? No? X-axis. 60 is here. 170. What is the x-axis? Right? What is the x-axis? Even. 510. How you get 510? Correct. 180 plus 330. Then you get 510. Okay. Here, somewhere over here. Okay, this one I remove the table. Move to this side. Okay. Now the point is 170 to 510, somewhere here. Okay, drag from these 2 points. T target is 60, T supply is 170. Hot, hot. Okay. So I drag this, hot. $510. So this is H2. $510, roughly lah. $510 over here. Okay. Now the distance for H2 must be 330. The distance. Okay. That's how you get the 510 for x-axis. We add up from 180, add up with 330, then you get 510 for the x-axis of the 170. Okay. So now this is your hot stream. Now combine them. Combine them. Okay, combine them. We check on the overlap area. Okay, where is the overlap area? Now overlap area. Okay, so between that point and this point. Okay, so this is your overlap area for the hot stream. Okay, now combine this H4 and H2 to get one stream of hot stream. Okay, only one stream. Okay, how to combine them? This point, okay, hot, hot. So this point, to this point, combine. Okay, this is the combined line. Okay, now, okay, now from here, we adjust it to become one straight line. Okay, now you have one straight line of hot stream. Okay, do the same for cold stream. Okay, so now we have cold stream. Cold stream, stream 1 and stream 3. Okay, so stream 1 from 20 to 130. Stream 3 from 80 to 140. We start with stream 1. Okay, stream 1. Okay, stream 1. Now, for stream 1, what is the x-axis for TS? Over here, stream 1. X-axis for TS. 0, correct. Start from 0. X-axis for 135. Here is 230. 230. According to the delta H. Okay, so plot from T as coordinate to T target coordinate. Okay, starting from 20 to 135. Okay, 135. Make it 135, is it? One 35, 230. Here. Somewhere here. C1. C1. Next, for stream 3, from 80 to 140. Now, this 80, what is the x-axis? 80. From 230, add in sorry, here is 240. Delta H is 240. So 230 add 240. What's the final value? Correct. 470. 470. Roughly here. 470. Next one 470. So here is 230. Okay, so starting from 80, 230 to 140, 470. Okay, so drag the line. Okay, focus on the blue color. Now we find the overlap area. Overlap area. Wait, let me copy. Easier for you to see. Yeah, I delete the hot stream first for you to see the cold stream. Now, this is the overlap area. From the 130 okay, then between this point. Okay, this is the overlap area for cold stream. Okay, then drag the point. Yeah, here between the yellow line. Then drag from this point to that point. Okay. So it would be if in one, if in one straight line, sorry, only one line for cold stream. Okay, it will look like this. Okay, so the tree area just now, as in the example, the tree area Here. It will be this part. This part. Okay. Okay, now we are done for cold stream. Combine both the cold stream. Okay, something like this, the cold stream. Now, after you get all the streams combined, it will look like this. Okay, just now we start from 0. Overlap each point. Okay, this is the original. Once you combine both hot and cold, okay, this is the streams. One hot stream, one cold stream. So this one should show moving upward. Okay, this one the arrow should go upward. Okay, now delta T mean 10. Move until you find the delta T mean equals to 10. The lowest point. Okay. Okay, so let's say here delta T mean. Okay, so this is your pinch area. Okay, this is your pinch point. Okay, so how to find the QH mean and QC mean over here? This is your QH mean. Okay, this part is your QC mean. Okay, and from here to here is your Q recovery. Okay, if you plotted properly, you will get your hot utility. QH mean would be 20. Okay, 20. This one would be 60. QC mean 60. Q recovery, you will get 450. Okay, so from here, hot stream, this is T pinch for hot. This one is T pinch for cold. Yeah. So up to there, any questions? Not sure what to ask. Go back and study first. Recall that. Okay, then tomorrow I will continue on the heat cascade. PTA. Okay, apart from drawing the curve, you can do the PTA. Problem table algorithm. Okay? Okay, so that's it for today. Thank you.